Good morning, everyone, and welcome to the Everest Plus and SMA webinar. We're going to get started in just 2 minutes. We'll start at 10:01 today. Still have some people trickling in, signing up right now. So we'll get started in just 2 minutes. So hang tight. Thank you. All right, good morning or good evening, depending on the part of the world you're joining us from today. My name is Tyler Wiggins. I'm going to be one of the co-hosts for this Everest Plus and SMA webinar. Before we get started here, just wanted to let you guys know if you have any questions at all during this time, please feel free to ask them in the questions section. You'll see there's a user interface you have through GoToWebinar, and there is an area for questions on the right-hand side. So please feel free to ask those at any time. We will be spending 15 to 20 minutes at the end of the webinar going over those questions. All right, so to get started, I first wanted to introduce myself. My name is Tyler Wiggins. I am the Product Development Manager at Everest Solar Systems. I've been here for about 4 years now. Basically, my role here is I'm responsible for managing the teams that design the racking components that hopefully you guys are using, or if you're not using yet, that you're considering using for your future PV mounting needs. I also work with the development team who designs the software that we're going to be going over today, essentially just making sure that the needs of our customers are met. So again, we kind of want to make sure that we're designing these systems specifically for our customers and our users. So we'll be giving some contact information out at the end of this webinar, but if there's any thing that you feel the tool is missing or needs improvement on, please feel free to contact us for it. A lot of the features that you're going to see today are in direct response from user needs. So we're trying to build this system to make sure that you guys have everything you need, so you can be successful in selling your systems and designing your systems. Co-host is helping us out today is Michael Mahone. He is a technical trainer at SMA America, so he's been there for quite some time, and I can read about some information here, and he will be taking over this webinar near the end to show us the wonderful tools that SMA has to help you guys design your projects. So at this time, I'm going to exit out of this PowerPoint and switch over to our website. So what you're seeing here on this screen is the main page of everestsolarsystems.com, and that is where you can locate the Baseon design tool. So how to get there, if you navigate to the top left of the page, you'll see this button that has 3 bars. This is our main menu button. If you go to your project, you will see a icon for Base Online Design Tool. We're going to go ahead and click there. And then you'll see a button that says Directly to Base. And that's the button that you want to click, and that will take you to our design tool. So if this is your first time using it, you might see at the top, it'll say where my name is here, it might say login or sign up. So if you do not have a login, please feel free to sign up. We try and get those approved within a 24-hour window to get you guys access to this tool. So I know we may have some users here calling in from different places other than the United States who use different units of measure. So you do have some options for how you want to design your systems. I'm going to be designing an Imperial today just because I live in the United States. That's the unit I'm most familiar with, at least with designing these systems, although a lot of our products are designed in metric. But if you do prefer to use metric units, you can change that at the top here. So we'll keep that in Imperial. As far as languages goes, we have quite a large amount of languages at this time. So if English is not your preferred language in the tool, you can change that to something else. And just a note on that, if there's something on here that you don't feel is translated correctly, please let us know. It is rare that we might have that issue come up, but if it does, let us know. It's not a difficult change for us to make. If you do have any questions on a particular function of a product in base, just to kind of give you guys a warm up here before we jump into the tool, we do have this question mark help button at the top. You can click on that and it will come up with basically a, it's like a table of contents here with just some parameters that we found can be challenging for some customers. So now that we've gone over that, we're going to be looking at a very basic flush mounted project today, just a simple cross rail design on a comp shingle roof. Since this webinar is not focusing on a deep dive into base, we do have those. We have done those webinars in the past. We will likely do those again in the future, but we do also have them saved on our YouTube page. And I get this question a lot during our webinar, so I just want to reiterate it now. This entire webinar is being recorded, and we will be providing a link to the recording either sometime today or sometime early tomorrow. So you will have access to that. So if you do end up having to leave early, not to worry, this will be recorded. You will be able to pick it up right where you left off and finish that webinar out. And again, we had, looks like 5 people join in the last minute. If you guys have any questions, please feel free to add them in the questions section of the user interface for this GoToWebinar. So to get started with the project, you're going to click on New Project here, this button on the left. And that will bring up our new project, basically the project page. So you have the option here, you can add in an address, and this is powered by Google, as you can see here. You can also add coordinates in. So if this is a new construction site and there may not be an address really established yet, you can add in coordinates instead. So we did just recently add that feature, so if you're a common base user, you may not have been aware of that. We're just gonna look at again, a simple project here. Whoops, a little ahead of myself. Simple project here in Southern California. Nothing too crazy for wind and snow loads, although we will go over how to add those in during this webinar. On this page on the left, so you see after you put in the address, it will bring up on the map where that project is located. You have some options on the left here to add some information. So I'm going to go ahead and just name this thing webinar project, and I'll just put something simple with the date. You can literally add whatever you'd like there. As design methodology, so we have had some questions come up. If you're located in California, Arizona, or Nevada, you may have seen that some of the new design codes, CBC 2019, ASCE 716, are starting to get implemented. So just as a note for base, right now we currently have coded the 716 regulations into base, but we are in the process of getting that certified with a third-party engineering firm. Make sure that it's essentially going to meet all of the needs of the jurisdictions that are going to be installing these in. So unfortunately, I don't have a expected date for that. We would like to have that done within the next 2 to 3 weeks, but it's going to take a little bit of time to to go through and verify that. So we are working on that now. We will have that soon. If you do have a project that is for 716, we do have certification letters. It's in a more older form, in the form of a span table, but we do have those available. Please get in touch with us and we can provide that for you. So that's where you would click. If we do have 716, you can click 710, 716, depending on what design methodology that jurisdiction is requiring. So in this case, we'll go with 710. I'll keep the author. It's going to automatically populate whatever name you have as your login, but you can change that if you'd like, and then you can add some information about the customer if you want as well. So go ahead and go into the roof tab, and we're going to draw this roof. Pretty simple user interface here. There's only really one button I can click up top, and that's this plus. If you're ever confused about what a button does, you can hover over it and it will tell you basically what it's going to do. So hover over this one, add new roof is what we want to do. You have some roof options here. In this case, we're going to do a flush mount style, just standard cross rail. So it'll be gable roof. We'll go ahead and click on rectangle. And we're doing composition shingles here. You could choose tile, trapezoidal, really whatever that roof type is. So we'll go ahead and click add. And then I'm going to come down here and click in the bottom corner of this roof. It's a single click. And now I can, whatever angle I want this at, I'm going to go ahead and click to here. We're just going to draw something simple for the sake of this example. And I'm going to pull it up to the ridge. So one thing I do want to note, when you're drawing these, it is best practice to start at the eave and then pull it up to the ridge. Let's say that you accidentally started at the ridge and pulled it down to the eave. Basically what that means is that the tool is automatically assuming that the first line you draw is the eave, and that's where that bottom of that slope is. So this arrow right here is indicating that this roof is sloping down, sloping down towards the eave, from the ridge to the eave. But if you accidentally misdraw that, that is not a problem. Now you can come over here to roof pitch orientation. Clicking the minus or the plus will change that around. So not a big deal if you forget, but best practice for this tool is starting at the eave and pulling it up. So the absolutely critical information that you need for this project is going to be highlighted in red over here on the left. The tool will not let you progress until you have added the information basically in these red boxes. So in this case, it's going to be building height. So let's go with something simple here. Again, arbitrary for this example. You will know what the building height is for this particular project. Roof pitch, again, I'm choosing arbitrary values here just for the sake of this example. So let's say that when we first clicked on that add roof, we accidentally clicked comp shingle. We should have you don't have to go delete and redraw. You change it here in the roof covering, which is nice. The tools down here in the characteristic substructure is a little more advanced. It may or may not be needed. It really just depends on the geographical location and building codes that were used for those particular structures. So in this case, Southern California, the rafter spacing is 2 feet. That's what the default is in that tool, since the majority of these projects are going in on structures with 2-foot rafter spacing. But you can change this to whatever it is you need to be. So if it's 16-inch on center, you can change that as well. And then I get asked questions about this too, distance to rafter from left edge of roof, which is essentially, we'll look at a little more detailed view later, but it's essentially a way for you to snap that rafter to the left or the right wall to sort of space those modules out. Obviously, when you get onto the site, we all know from an installer perspective that those rafters are not always located exactly 24 inches on center or where you would expect them to be. So again, I want to state is that this tool is not pulling any data about this particular. It does not know where rafters are located. Whatever we're drawing, it's just basically snapping it to 2 feet on center there. So it has no way of pulling data on this particular structure. So it'll always be the responsibility of the engineer of record or the installer to, make sure that what they're designing on this tool is accurate to what they're seeing in the field. So again, this tool is making some assumptions in this case, assuming that these rafters are 2 foot on center, which for the sake of this example, we'll just assume that that's correct. All right, so once we have all of that information in, I'm gonna go over here and click on design. And some feedback I get is, it's kind of hard to design being this far away from the roof. And the question is, why can't we zoom in any further? So again, since this is powered by Google, we are limited on how close Google was able to get that satellite image. In some cases, you may notice that you can zoom in a lot farther than in others. And it really just depends on what the data was provided from Google in that particular case. So in this example, we really can't get that close. So it's not, I would say that this is not the easiest screen to design in. So what we added is a 2D feature. So if you scroll up to the top, you will see this button that says switch to 2D view. So if I click on that now, it basically is just making this a very simple rectangular shape that I can easily manipulate and deal with. So this is a screen that I prefer to work in, depending on the size of the project. If you are in the commercial space and you're looking at something like DDOM, it might be easier to work in the satellite view to understand where those obstructions are. But in this particular case, I like to work in the 2D view. And that's, again, one more thing I would like to note, which we get feedback on, is that as far as the updates of these images, we are limited to what Google is able to update and how often they are able to update. So design a project purely based off the satellite view, doing a inspection of the site can potentially have some challenges. So it's just one thing to note that we really have no control over how often Google is updating these. So I would recommend, again, just kind of reiterate that it's always best practice to do a visit of the site and see how accurate those satellite images are compared to the actual project. Those real world, things you're going to see out there. All right, so now that we're in the 2D view, put our module on the roof. So we have a huge database here. Some feedback we got from customers that the database was not filled up enough with the most current modules. We now have every single type 1, type 2 module available in the world, at least that we are aware of, and this is basically updated every week. So thousands and thousands of modules on here now. So hopefully we'll always have the module that you guys are looking for. So for this example, I'm just going to go with something simple, go with the LG. I know most of you are probably familiar with that module. We're going to go with a 350 N1C, which we have all of their most current modules here. So we'll scroll down. These lists are in order alphabetically, which typically means for these models are going to be in order by the wattage. So we're going to go with the N1C Neon 2. Again, just arbitrary for this example. It will self-populate the required information that it needs to place these modules on the roof. You can also do a user-defined module if for some reason the module you're looking for is not on the list. You can click on user-defined, and then you'll be able to put in a custom module in there. So in this case, we won't do that. We'll go with this LG. So now I'll click on module arrays. And then very similar to putting in the roof, I'm going to click on the plus, which is add a new module field. So Base will understand what roof you're using and give you your potential options. So in this case, since it's a sloped roof that is comp shingle, there are only 2 options, which are shared rail and cross rail. In this example, we're going to keep it simple, go with a cross rail system, which is a standard dual rail system for those who aren't familiar, which is 2 rails running under each row of modules. Shared rail, meaning that that rail is splitting those rows of modules. So you can save some components going with shared rail. For this example, we'll just keep it simple with cross rail here. So now I have 2 more things I need to click. Do I want Base to fit as many modules on the roof as possible? If that's the case, I'll go with complete roof. Or you might want to select module field where you self-draw that module field in there. This is more common if maybe one part of that roof is already taken up with, say, solar thermal. You can't put modules there anyways, so you might just want to draw that field in. In this case, this roof's wide open. It's literally nothing on it, so I'm going to go with complete roof. And then I have my option of choosing portrait or landscape. Again, you can toggle between these two, so making the decision now is not going to affect you long term. You can always change that. So I'm going to go with portrait for this example and click on add here. And we'll see that it's adding as many modules as it can fit in here. So you might see that there's a gap right in here. So what that is a thermal gap, just letting you know that that at least with Everest systems, there is a requirement, essentially every 65 feet, that there needs to be a thermal gap placed between those modules. So in this case, it's not 65 feet. It just had a default to 5, but you can add this to like 12 modules and break it even more than that to fit these modules in. So what I'm noticing about this is in previous examples we've done, this is able to fit 20 modules. So my guess is that I did not put the correct dimensions of the roof in. So if you go back here, maybe you've measured it on the roof, for example, and let's say you draw it in, you're like, hey, I measured that I was able to get 20 modules up there, but now it's only showing 18. Why is that? It may be that you didn't pull this all the way across enough to that roof edge. We can see it's kind of hard to see in there. And maybe from measurements, we found that, actually this roof is 37.5 feet across, not 35.8. So you can click on there, change that to, we'll just say 37.5. Go ahead and click, and it's going to space that out now to 37.5, and we'll see that it fit more modules on here. Again, with this thermal gap default, that is being changed back to its standard, which will be, I forget what the module count is, but it's essentially making it so you can't do an array of greater than 65 feet. So, but if you did, let's say you did want to put a thermal break right there, like maybe there was a vent pipe and you wanted to have a 6-inch gap, for example, you could split it, break it every 5, which will put that break right there, and then you can change that to whatever gap you want. Maybe it's 6-inch to handle that vent pipe, and it will split that for you. So in this particular case, for this example, we won't look at any thermal breaks today, but that's how you could account for that if you wanted to. Let's say you wanted to delete some modules. Maybe you want to delete this module on the left for whatever reason. You can go into the design tab, click on the erase button here, and then we can delete that module and this module. In this particular example, we'll leave those in there. That way we have all 20 mods on there. And we will continue onto the loads tab. So in the loads section here, you'll see that it's pulling up the address. It's letting us know what our design methodology is. And then we have some things like wind exposure and risk category. So for those of you who may not be familiar with wind exposure and you're not sure what to pick, I would definitely consider consulting either the AHJ or the engineer of record. For most of these suburban projects, they will be exposure B, but I can't comment for every project. Every project is different. Every AHJ is different. It's always best practice to consult the engineer of record or the jurisdiction to see what that wind exposure category is. And same with the risk category. In general, most businesses and housing are risk category 2. When you start getting into 3 and 4, it's typically, hospitals, fire departments, things like that, or schools. So if you're working on any commercial projects like that, you will likely, more than likely, almost guaranteed have an engineer of record on those projects. So consult with them and see what risk category is best for that particular structure. So one thing to note, at least currently with our Everest systems, we're only pre-engineered to risk category 2. The reason for that is pretty much every time a risk category 3 and 4 structure is going to have project-specific engineering anyways. There's a lot of variables to take into account for those particular projects. So these systems, all the spans you're going to be seeing here are for risk category 2. If you get into 3 and 4, you will need to consult the engineer of record on the project. Wind speed, this is based off of the design code. So in this particular case, it's going to be ASCE 710. If you're unsure of what the wind speed is, 3 options really. First, consulting the engineer of record would be best. If there's no engineer of record on a project, you can consult the jurisdiction and see what their requirement is for that particular area. If still you're not able to get any positive information from them on that, you can click on ATC wind speed by location. Most engineers are using this anyways. You can copy and paste the address into there, and you can get some information from them. So, and here we can see ASCE 710, risk category 2, it's 110 miles an hour. So that's what we will be using today. One thing I do want to note is that in future versions of BASE, we are going to have this information pulled automatically for you based on the address that you put in. You will, of course, have the option to override it, as some jurisdictions do override what the ATC recommendation is. They have the final say, so you have to go with what they choose. But we will have that option in the near future. And then snow load. This is, in this case, we're in Southern California, won't be adding any, but at the same thing, you can go to ATC's website, pull that snow load if you're unsure of what it is, and add that in there. There will be a calculation that's done automatically converting ground snow load to roof snow load. You do have the option of overriding that to put the roof load in manually, again, if the engineer of record or the AHJ is requiring a specific roof snow load, you can add that in. So now that we have that information, and we're going to go ahead and go into results. I'm going to go a little faster here to make sure we have enough time for Michael to go over SMA's tool. So you could, so there's a couple things you can do here. If you go to the top, you'll see there is a button for looking at some different options here. If I wanted to look at the roof structure, when we talked about earlier, the rafters off the left wall, you can see it's just kind of defaulting, basically putting a rafter in the center and spacing them out 24 inches. You can default it off one wall, so we could look at that. The rails, the blue lines are the rails, the modules are the gray boxes here. You can click on those to get some information on them, look at the rails, look at the spacing. You will see that at this time, BASE is automatically staggering the attachments for you, since most engineers are doing that, and installers for best practice. Although, again, depending on the project, you could, of course, put them all along a single rafter, but again, that's project dependent. So from the feedback we were getting from customers, staggered was the preferred default, so that's what it's defaulting to now. In the future, we will have an option to do a non-staggered attachment method as well. So you can add here, if you don't want some of the, we'll call them non-critical items like end caps, wire management clips, things like that, you can uncheck them here at this time. So if we go into the summary tab, we'll see our bill of material here. I get this question, what if I want to add extra material? You can definitely do that by clicking on Edit BOM, and you can add, like, let's say that you're unsure about the rail count because there's some obstructions on there and you just want to have some extra for whatever reason. You can just make that 12, hit apply. It's going to highlight it, basically letting you know, hey, you modified this. You added some extra material. So if you're unsure of what these products are, you can hover over this little spyglass thing, and it'll give you a picture of what that component is. And this more general information about the project. If you click on the generate button, it will generate a report. Again, we'll go over this pretty quickly here. We'll make sure I leave enough time for Michael and SMA, as well as our questions. So I'll just go ahead and click open so we can see that. Maybe, here it is, okay. And let me zoom out here a little bit. Ooh, that's in. We want to go out. There we go. All right. So you'll see there's some general information about the project here on the first page. The module we used, very basic assembly plan, some more information about the roof. Again, you know, projects change when you get up there, so keep that in mind when looking at these. Doesn't take into account project-specific information. Information about the snow load, wind load, dead span tables, and then finally the bill of material at the end. So just some general information about the project. All right, so without further ado, I want to show you the new tools we have with the integration with SMA's tool. So now that you've finished designing the project and you want to go over to Inverter Design, you click on the Everest plus Inverter Design button here. Click that. We'll click on SMA Sunny Design. And now it's going to be exporting that project to SMA's tool. So you may get a login page if you haven't already logged in with Sunny Design, so you can log in there, and then it will immediately bring that project into Sunny Design. All right, so Michael, I'm gonna go ahead and pass the ball over to you and let you continue from here.
Awesome, well, thank you for that great intro. And yeah, definitely, let's
do that right.
See if I
think you should have it now, Michael.
Okay, and let me show my screen. Okay. Okay, can you make me presenter? I see show screen, but I do not have an option to.
It's showing your screen now. It has it on go to webinar, let's get started. That's the screen it's showing now.
Okay. Let
me click it again.
Yeah,
it has you as presenter now.
Okay. Okay, click to start sharing screen.
1 second here.
Yeah, no, apologies.
I'm not sure what's happening. Yeah.
I'm going to try and make myself. Oh, there we go. I think I grabbed it.
Yep. There you go. Perfect.
And does this show the Sunny Design screen or the open screen?
It does. Yep.
Okay, perfect. Okay, well, definitely thank you. I'm going to go ahead and bounce into the project file. So again, my name is Mike Mahan. I am one of the technical trainers for SMA America. We're going to go through a lot of the features of Sunny Design that you see here fairly quickly. Again, we wanted to emphasize the handoff between the Everest base tool and Sunny Design. We definitely have recorded webinars that dig deeply into a lot of the features of Sunny Design. If you do not have an account on Sunny Design, it is very easy to get a free account. If you go to sunnydesignweb.com, you can sign up for a free account. If you use SMA equipment and have an account on our monitoring portal site, Sunny Portal, that same set of login credentials will work with Sunny Design. You can use the tool without logging in, but none of your projects will be saved if you do that. If I go back to my home screen, you can see the list of projects here, and we've actually grabbed the same file that Tyler used out of his Sunny Design, and I've brought it over to mine to make sure there were no technical hiccups. But the first screen you see is the screen you saw him import the project into. The project name I have is slightly different than what he had, but the name will import. The location will be close, and we'll talk about that. And then some of the information for the PV system has already been imported. So these are the two important screens for the design for the inverters. While prepping for this webinar, we did see some interesting issues with different browsers. Potentially, this may import as a different project type if you have not configured your personal settings yet. We were using Chrome and saw some interesting behavior. It appears to work very well with Firefox, so I'd generally recommend using Firefox for this. But if you do see when you come into the project a screen that asks for load profiles, what it means is that Sunny Design has chosen one of these lower 3 project types to import rather than the one that is most common. In Sunny Design speak, PV systems without self-consumption is a straight grid-tied PV system. This could be residential, commercial, or utility scale, but there's no storage associated with it. The other project types with self-consumption would be grid-tied storage. Off-grid obviously could be PV, but also with an off-grid inverter. So if you see a screen in the project file that asks for load profiles, it may have imported as a different project type. So pay attention to that. Generally, we're assuming everyone would want to use the without self-consumption. So hopefully that would be the correct import. And again, that may be browser dependent, but it's also something you should set in your profile. So once you create an account, when you log in, you'll have at the top right a My Sunny Design pull-down menu. And the first choice in that is settings. And in the settings tab, you will have the ability to set a default project type. This will not be chosen when you create your account. So I'd recommend generally if you're doing PV designs without storage, select this PV system without self-consumption. That should ensure that the imports are correct. You can also enter default locations. As Tyler said, for their tool, there are ways to swap units. If you're working outside of the US, an EU listing for equipment is more important than UL. You can make those modifications as well on this settings screen. So there's a lot of configuration that you can do in this project with Sunny Design. One thing that will be slightly different is that Sunny Design, the important bit for the inverter's yield calculations is primarily irradiance. And so we don't have the tool driven by a geolocation service like Google Maps. So the Oakview project, if you look at Google Maps, Oakview is roughly here in Southern California. And if you look north, you'll see Bakersfield up here. And if you look at the imported city, it was Bakersfield, California, because the default city list for the US is not actually all that huge for Sunny Design. Every location here with an asterisk after it is one that I have created. So Bakersfield, California likely is not really the best reference point for the irradiance that you might experience here for the location site that was in Oakview. So if we look around, we'll see, okay, we have Camarillo, we have Oxnard. Sunny Design has the ability to pull in external data files for locations, many more choices than our default database. Generally, those are data sets that have been collected at airports or naval air stations. So if you feel that Bakersfield is not the right choice, and again, with a very large topographic feature between the two locations, that's likely a good observation. If you want to change this, if you click Create Own Location in Sunny Design, you'll have the ability to create a new location. And don't be fooled to start filling in some of these fields manually. If you want to import data, click on the Imported Meteorologic Data tab here, and you'll see that some options appeared when you click on that. And I'm going to click on the Energy Plus weather format. This is the file type that can drive Sunny Design. So when we go to this link, it's going to actually open an external website for the Department of Energy. And I'm going to select, you have lots of choices here, but I'm looking for something in the US. So I'm going to click that, and then I'm going to click California. So just for California, there are a lot more choices. Again, a lot of these you'll see airport, or you might see, Meadows Field or a naval air station, naval airfield. Unfortunately, the names might not match exactly with the city they're closest to. You do see that you have Camarillo here, but also we had the Point Mugu Naval Air Station. So I'm actually going to choose this Point Mugu, so that was not very far. So you'd have the Camarillo or Point Mugu that would probably be far better choices to get the accurate representation, the best results out of Sunny Design. So if I click on this, you can download all three files, but if you remember, it's the EPW file that was important. So I'm going to click on that, and I'm actually going to save it to your local machine, and then don't open it, but go back into Sunny Design and ask Sunny Design to open it. So I'll import this, and I have it, I believe will be on my documents page, actually, sorry, downloads page here. And you see here, Point Mugu, and it ends in EPW. So I'm going to select that file, open it, and then a lot of these fields should be populated by default for you. It will create this location. We do need to set this as actually in the United States. And I'm going to call this, I'll say, point is my, location. And the default tilt angle and the orientation, generally I'll say 18 degrees, and I'll put due south in Sunny Design is 0, not 180 degrees. And the dimensioning factor is simply a way to get a flag from Sunny Design if your DC to AC ratio goes too out of whack. So I'm going to do that. I'm going to select this as a 240 split phase system, something that would be common in the US. And I believe that's the required information. You can see the data that Sunny Design is pulling in. So I'm going to then say save location. So now we'll be changing from Bakersfield if I want to use this. And I'm going to say yes, and this might actually have overwritten. I should have shown the default orientation. I don't know if it's going to override the orientation and tilt. It did. Okay, well, I may reopen the project or import it. So I did actually overwrite what we pulled in from Everest base. For the location, now we have the irradiance pulled in by the city location. Notice also there's actually a temperature range that was pulled in by Sunny Design. This is based on a European database that is very, very similar to ASHRAE data, but there's no guarantee that this would be the same as ASHRAE data, and it will certainly be less conservative than using the historical low and historical high for the site. So it's very easy to adjust these. Whoever the person who is performing the design should put in the appropriate values, check to make sure that these either are acceptable or change them if they want to use something closer to historical min. It's very easy to adjust the numbers manually. So verify those. Choosing the location has put the irradiance map that the program will use. The temperature range can be adjusted here. There are a few other things that Sunny Design can consider. So NEC 2017 is actually looking at some different ways for calculating current, maximum current, UL 1741, SA Rule 21. These are smart inverter functionalities. This really isn't a constraint. All of our string inverters are certified to 1741 SA, but you can adjust these as well if you're outside of regions where they don't apply. The last thing that is really important on this screen to choose is the inverter grid connection. This will adjust the filter of inverter choices that you are allowed to see. If I don't choose anything, when we go into the design, I would probably see our Sunny Boy residential string inverters, as well as our Core 1 three-phase commercial inverters. As we're assuming this is a residence, I'm going to choose 240 split phase. That's a very common residential connection voltage. So this will prevent those Core 1 three-phase inverters from showing up by default. We would need a transformer between the inverter and this service type for that to work. So it will only show the inverters that can natively connect to this grid type. So location for irradiance, verifying the temperature range is what you find acceptable for your design, and choosing that inverter grid connection are the important objects on this first screen to set the location. You can modify other things like the line losses. When you get the energy yield, you can design the system so that the DC line losses and the AC line losses to the point of PV tie-in are actually taken into account. So that is, you can customize even further. But let's move on to the second tab, the PV system, and you can click the PV system button at top, or you could click the next at the bottom of the first screen to get here. I unfortunately wiped out the orientation and tilt that was imported from Everest base, but you can see that the LG Electronics modules, the 350 N1C, the 20 modules, and actually it would have 21 degree pitch. And what would have shown up actually, and again, I want to emphasize this, if you need to change anything, simply click on this icon. We had from the base design, we were off at 330 degrees. Again, Sunny Design uses 0 instead of 180 degrees as due south. So going a little bit to the east is actually going to negative. So we would have been at about, let me get back to minus 30 is about what we would have seen for that. And again, I can put this back up to 21, which is what we had designed. And if there is a different type of mounting style, generally roof is the default, but you can adjust the mounting style as well. What this will affect is the temperature that the program assumes the modules are running at. Obviously, there's less airflow when these are mounted on a roof versus a ground mount, and if you hover over the tile, it'll tell you what the program is doing in terms of increasing temperature towards the heat of the day based on ambient temperature for the location. So with that selected, and again, if somehow the import didn't work or you wanted to adjust things, it simply click on the tile to adjust the number of modules. And again, the module database is quite large. You can adjust those as well. The choice of any type of MLPE does not adjust the output of the program. The TS4R-F units that SMA would recommend for 2017 NEC 690.12 rapid shutdown compliance would be a device per module. You saw in the Everest BOM that the clips for attaching those to the racking were included. Those devices can actually just slide onto the module frame. So it's possible that those items are not needed, but it would be generally a TS4R-F device per module for that 2017 rapid shutdown compliance. That device actually is for residential or commercial, even though we won't do commercial design today, it would work for either of those. But again, those are code compliance devices. They're not going to change the design rules because they don't adjust the module's output voltage or current. So that is a very nice thing. They do not adjust the design results if you happen to forget to include them. With the location and the array information in the program, now we're ready to do the actual inverter design. Below the array, you will see you have your choices for inverter design. You can have the program automatically design for you. You can manually choose, or there's this design suggestions button. Oddly enough, I never recommend anyone uses the automatic design button. That is the default. The program calculates everything it possibly can, and so sometimes it overthinks things. It will consider a 0.1% difference in energy to be an optimal design, even if it means you use 2 different inverters of different sizes or have the arrays strung in non-logical ways. So sometimes I think the program overthinks things. What I like to choose is design suggestions to start with. You'll get a screen and it asks, how many inverter types can I throw at you? I generally leave it as 1. And then the other 2 choices don't really matter. I only really like to see 1 type of inverter per project. Based on our grid tie-in voltage, we're seeing Sunny Boys, not our tri-power 3-phase commercial inverters. And we have a few suggestions thrown up for us. The sorting by default is on profitability. Let's choose energy yield instead and see how these rank. We had, I believe, with the 20 modules, a 7 kilowatt array. So we have a 6, a 7, and a 7.7 kilowatt inverter. And you can see the program is thinking very strongly on these, that really these are probably the top 2. It is very straightforward to choose a much larger array than the inverter. If you go to the data sheets for the Sunny Boys, you will see that they support a very, very large DC to AC ratio. So really, until you're getting close to 9 kilowatts, would you need to worry about the DC to AC ratio for the Sunny Boy 6 being too high. But let's say I want to look at the results for 2 different. I can compare these 2 choices. They seem very similar. 7 kilowatt is inverter is a 1-to-1 ratio for the array, whereas the 6 is a little higher. That may be within your design comfort level. Likely it could be. And you see that this program window will actually show you the specific energy yield and the actual energy yield between these 2 choices. So it does show that the 7 kilowatt inverter does produce a few more kilowatt hours annually. But that's not a huge difference. That's what, about 50 kilowatt hours annually for probably a price difference that may be fairly noticeable. So again, up to the designer to choose what makes sense for the system here. One thing to look at is if you want to have an idea of how often the program thinks attaching a 7 kilowatt inverter with the tilt, orientation, and physical location that the program has into a 6 kilowatt inverter, the energy usability factor is that metric. If that number is 100%, the program is stating it never believes that that array with the STC rating it has and the location, the tilt, and orientation would ever be able to send more than 7,000 DC watts to the inverter. If it's slightly below, it does say that 0.5% of the time, it is thinking that the array, the 7 kilowatt STC rated array, could send more than 6,000 DC watts to this inverter. The output of this inverter is clipped at 6,000 AC watts. So then you would be working off of the maximum power point. So this energy usability factor number is a very good number to look at if you're considering 1.2, 1.3 DC to AC ratios or higher. For the sake of discussion, I'm going to actually choose this one. And so I'll simply click Adopt Design. That will pull this inverter in to the design tool. We've seen a little bit about the energy yield, but one thing that is absolutely critical to look at in the program is to make sure that there are green check marks in the design area to the right. That is the physical safety checks for the inverter. The Sunny Boy line cannot go over 600 volts DC. Each input channel, there are 3 independent tracking input channels for this device. Those can be exposed to a maximum of 18 amps ISC. The inverter will run them at up to a maximum of 10 amps, so that's the operational limit, but the 600 volts and the 18 amps are essentially, you can void our warranty by going over these. So checking for green check marks across the board here is critical. You can see that you're getting close to that operating limit for the inputs, but you're not, and that the typical PV voltage is well within the inverter's wheelhouse. Like I said, there are 3 inputs to the inverter. If you want to change the stringing, the program has put a string of 9 and a string of 11 into the inverter. Because it calculates, that will generate more energy. If we adjust that to something a little more rational, to a 10 and 10, like someone might originally string, we'll see that change in energy, but it'll be a slight change. Note here on this screen, we have the 3 inputs to the inverter. We can see for the modules we've chosen, based on the current limits, 1 string per input is what the inverter says will work well within the design limits and will not go over the short circuit current limits. Similarly, a string of 4 modules will stay above the start voltage, and a string of up to 13 will stay under that 600 volts on the coldest day. If you go outside of that, you will see red X's, and the program won't stop you. So you could put a 14 there, and then you'll see a big red X will be going over 600 volts on one of these inputs. So you get a lot of X's if you do something untoward. But like I said, you would see that 11 and 9 because the program thought that that would yield more energy than the 10 and 10, and it might by a few kilowatt hours a year, I think by 1 kilowatt hour a year. So feel free to adjust those designs, but the important bit is to make sure that when you're done, you have the green check marks across the board here for your inverter design with this array. There are some other screens here. I do not want to spend time on those to leave time for questions for this webinar, but feel free to reach out to me. And we do have recorded webinars on Sunny Design that go through all of these screens. There is a very easy way to output some documentation from the program in terms of how the system performs with energy yields. There is not a tight BOM integration with the Everest tool, which I think would be very, very nice to just tack the inverter onto the project. But the documentation that Sunny Design generates could be included with the documentation from the Everest-based tool, and you would have lots of very good information all in one location. I think that is all I feel that is absolutely critical to cover on the Sunny Design part. So I think we are ready to open it up to questions, if that makes sense.
Yeah, that sounds good, Michael. Thank you for going over all of that. So again, for anyone who may have arrived late, if you guys have any questions, you will see a question section in the user interface for GoToWebinar. So now is the time to ask them. Please feel free. I've got a couple in here already, so I'm going to go over those. For anyone who joined late as well, this webinar is recorded. So I get that question a lot sometimes. So we did record this webinar. We will be sending out an email either later today or tomorrow, so you can catch up on anything you may have missed. So let's go over the first question here. Can BASE calculate wind speeds for locations all over the world or just the United States? Great question. So a little bit of a long answer with that. The answer is yes. You can, you can input any wind speed in there between 110 miles an hour and 200 miles an hour, because right now the code is that we're using for the calculations is per ASCE 710, and those are the wind speeds per risk category 2 structures. So what you might say here is, Michael, let me take, I can just take control.
Okay, okay.
Yeah, no problem. It's all right. Yeah, that's a good thing. I'll show it to him for sure. Give me 1 second here, screen. Yes. 1 second here, sorry folks. All right, show screen on the right. Okay, so let me pull open BASE here. So in the load section, you'll see you have these wind speed options, 110 up to 200 miles an hour. So what you might be saying is, well, the jurisdiction I have only has to go up to like 80 kilometers per hour, which is, not even close to 110 miles an hour. What is the best wind speed, applicable wind speed for me to use? My best suggestion for you is that if you're calling in from Europe, if you're calling from Europe, you're probably using K2 systems, not Everest systems, but if you are, you can get in touch with one of our many offices out there. We have an entire group in the UK, France, Germany, Italy, and I think some other countries as well in Europe. So you're more than welcome to contact K2 Solar Systems out there, and they can definitely help you out with that. If you are in North America or South America, we do have an office located in Guadalajara, Mexico, and our team down there is very specialized in figuring out what the best applicable wind speed is for your location. More likely than not, it's going to be somewhere between 110 and 130 miles an hour. But if you are in a hurricane zone, it may be higher. As a note, too, we are currently working on getting the mountain design codes implemented into BASE. So if you are installing in Mexico, that's something we're working on right now. It's taken a little bit longer than we wanted to, but it is currently being added to the build. I don't have an exact date on when that will be completed, but we're definitely shooting for the next couple months. So I will update you guys when we know more. We will definitely have a webinar on that once we know more. See, the next question here is, when will ASCE 716 be available in BASE? I think I was talking about that at the beginning of this webinar. So if you go into project here, you will see the design methodology, ASCE 710, 705. We are currently right now adding 716. We do have the calculations in BASE. It's on a test tool, so our current users won't be able to see it, but I have been messing with it pretty much every day for the last couple weeks. But we are in the process of debugging that right now and having a third-party engineering firm validate those calculations, which will also include a stamped engineering letter and certification letter for those calculations. So the future of BASE is you'll be able to design your project in BASE. When you print out the report, we'll also be able to print out the certification letter that's basically certifying that those calculations were made to CBC 2019 or ASCE 716, whatever it is, that particular building code for your state or jurisdiction that you're installing in. And that will be, that will essentially be the future. We'll have some more calculation options, be able to do higher building heights and things like that. So a lot is being added right now, and we will do a webinar for that as well once those things are added. Next question I have here, will Sunny Design continue to add more default locations in the US? So I'll hand that question off to you, Michael.
Yeah, I think so, but I would strongly suggest going ahead and looking at where the install is and using that import meteorologic data to find a location from the DOE website that is closer by, that would have more representative irradiance. I think that's going to have more options than what you would see from us adding a few more default locations in the United States. So I think it's a very easy way to grab that historical data from the DOE website. So I would really generally suggest doing that rather than waiting for more default locations.
Got it. Perfect. Okay, this next question, I don't know how long this one takes or not, Michael, but the question is, can you show how to string the inverters on a project?
Oh, okay. If you, I did show that very briefly on the PV system screen.
Okay.
When you have the inverter chosen, to the right of the inverter name will be there will be 3 tiles. You can have, we only showed 1 PV array for this project, but you can have up to 3. Yeah, thanks. You can have,
Yeah.
so we have 1 PV array. You can have up to 3 per project. So that's why these 3 boxes are there. For that PV array, we have the 1, so we can choose that button below it to do the stringing. So the inputs A, B, and C are the 3 input channels on that Sunny Boy inverter. So you have the ability to break the PV array 1, all of those 20 modules across those 3 inputs. So all of the modules are coming from PV array 1, but we're taking 10, attaching that string of 10 to input A, this string of 10 to input B. And again, you can adjust the default for the program doing the automated stringing was a string of 9 and a string of 11 to get slightly more energy. But generally, the uniformity will make it a little easier to service in the future, or just comparing the voltages across the 2 channels on the inverter to make sure everything's working right. 10 and 10 is a more rational choice. So it's very easy to adjust those by clicking on the buttons to the right of the inverter icon once you've chosen the inverter.
Perfect. Okay. If there's any follow-up questions, please feel free to ask it, and we can cover that in more detail if needed. I'm going to continue on here. Got some more questions. This one says they're joining from Mexico, considering that you use the products to adapt the design platform for a country in the future. Yes, so that was similar to that previous question. We are working on it now. We've definitely heard you guys, and again, I'm apologize for the length of time it's taken. The codes in Mexico are very different than the codes in the United States. So it's taking a little bit longer to figure out how we're going to adapt base to meet both the codes in the US and the codes in Mexico. So we believe we have a solution. We're working through it right now, but it is going to take some time to debug that, unfortunately. So it's not something we can do quickly, but we are working on it. It's a very high priority for us. We have definitely heard you guys on this one, and as soon as we have some information, we will absolutely be having a webinar on that to go over what those changes are and if there are any additional needs, what they are as well. So looks like we have our final question. Once finishing the project in base and SMA, will there be one document showing all of the project info? So at this time, I don't believe we have that, unless I'm mistaken.
Yeah, I'm
Michael,
unaware of an integration, but you can
yeah.
kind of see what the SMA tool has as documentation options, and you can select the parts that are included in the report from the project. And I think having, you know, the inverter document and then really the PV array and racking hardware document, even as 2 documents, they're very complementary because you'll see there's no array layout information here. This is all very specific to the inverter and production from the full design system. So it is two documents. You can do the same export from Sunny Design, but I think they're very complementary.
Yeah, I agree with that too. I think that's probably the easiest solution. I mean, you know, to fully answer this question, anything's possible with these tools, you know, and when I say anything, I mean mostly anything. You know, maybe there is an integration we can look at one day where when it exports the file, it also pulls the PDF and it is able to push all of them together, and your printout includes both just in one easy. But that has not been an immediate need that our customers have made us aware of. I think what they're doing now is they download the Everest PDF, they print that out, they download the Sunny Design PDF, they print that out, and that's, you know, pretty much all of the information that they need. So at this time, I would say there's no immediate need of combining them into one, but like I said, we're open to all customer needs and feedback. So if something comes up that you guys would like to see, which kind of leads me to our next slide now that we finished our last question, is you are more than welcome to contact us at any time to you know, let us know what you want to see. I'm going to go ahead and take control of the screen here real fast. Actually, yeah, there we go. Make sure I have the right screen here, monitor 2. And just bring up our final slide with our contact information here. So again, if you guys have any questions about what we covered in the webinar today, it will be recorded and will be sent to you so you can go over that. Any additional questions, you're more than welcome to reach out to us. We have an inside sales team in the US. If you're calling in from Latin America, we have a very large inside sales team located in Guadalajara, Mexico. And you can go on everest-solarsystems.mx to find their contact information there. You can also give us, if it's something general, you can get us at info@everest-solarsystems.com. Or if there's something for me that you want to have, you have my contact information here. So again, we're always open to feedback that our customers have. And if you guys are base users and there's something new that you want to see, please feel free, send us an email or give us a call, and we'll see what we can do. So Michael, I don't know if you had closing statements you wanted to make.
Not really, but yeah, like you had mentioned, if there are very specific questions for Mexico, we have you know, a project manager and sales manager for Mexico that could very much handle any questions. So you feel free to route those through me. I will be forwarding them on to our colleagues in Mexico, but definitely we have some people who could handle those as well. So yeah, anything that, even if it's sales related, that I would not be able to answer, I am more than happy to forward those on within SMA.
Perfect. All right, sounds great. Well, thank you everyone for joining. As I said, you'll be seeing that email soon with a recorded webinar. And I hope you guys have a very successful week and a very successful year. Everyone's expecting big things for solar this year, including myself. So I wish everyone the best. If you are going to be in SPI Mexico, we will have a booth this year. So please feel free to get in touch with us. I will be there, so I'd love to talk to you guys. My Spanish is getting a lot better, so hopefully you can have a good conversation. But love to meet you guys and talk to you guys. So I hope you guys have a very successful year, and thanks again for joining the webinar.
Very much, yeah. Thanks, everybody.
Yes, bye-bye.